Okay, well, I think I can go ahead here. It's 11 o'clock, so this is our third of the breakout sessions. My name's Dan Thiedens, and I'm a research scientist here at the university. So I am actually sitting inside the MRI room right now. This is not part of the hospital, so obviously they have many different MRI scanners in the hospital. MRI stands for magnetic resonance imaging, and this is essentially a way that we can look inside your body without having to do surgery on you, which is a very positive thing. Excuse me. So our system that we have here is basically just for research. So all we do down here are research studies. A lot of the stuff we do is brains, but we also do hearts and livers and lungs and muscles and ankles and knees and all sorts of stuff. But I will say that the most common thing that we do is scanning brains. So we'll start off with, I'm going to be hopping up and down here a little bit. As I mentioned, I can't go right up to the scanner with my computer because of the big magnet. And basically, this whole thing back there is a giant magnet. So the little tube that you're seeing back there is an electromagnet. An electromagnet, if you've ever had this in science, you can make one just by wrapping wire around some sort of form and then putting electricity through it. And that's really basically all that is. It's a very big tube. It's probably, I forget if it's 60 or 70 centimeters around, so close to 2 feet around, 2 or 3 feet. And it's wrapped with literally miles of wire. This wire is this real exotic type of metal. I forget if it's niobium tantalum or some of those kind of weird metals that are way off on the old chemistry chart. And it's got a lot of electricity running through it. So many, many amps of current running through it. And so what that allows it to do is just to be a very, very strong magnet. So again, it's not fundamentally different than the magnet that is, holding up those drawings maybe you did in kindergarten that's on your parents' fridge, but it's just a lot more powerful. There was the cartoon earlier with talking about the compass. The Earth's magnetic field is enough that it can make a compass point to the north or south or whatever. This is about 100,000 times stronger than the Earth's magnetic field. So when you walk in here, you're not immediately up against a big magnetic field. So the magnetic field gets stronger as you get closer to the magnet, but it still is significant. And so back here, nothing much happens. So I can set my computer in here, nothing much is happening. But I'm going to go up there in a minute. This is just my belt. This is a regular belt. It does have some metal on it. So this part of the metal, as it turns out, is not attracted to the magnet at all. But the little tongue part of it is. And so I'm going to go up there and just show you, once we get this a little bit too close, what's going to happen here. So again, this is basically not much bigger than a paperclip size of this tongue in here, but it is made of material that's attracted to a magnet. And so I'm going to take my microphone off for a second and walk over to the magnet. And so hopefully you can see in there, this is basically making this kind of levitate. I'm holding it back at this in here, but the force that this giant magnet puts just on that little paperclip sized tongue of the magnet is enough to pull it in there. If I let this go, you can see it can, at this point back here, it will just sit on the table. But if I let this go, it'll go flying into there. And so this is the kind of stuff that always, when we're talking about being around the big giant magnet, we have to be careful of, is that we're not bringing something that is magnetic in there. So again, this is small enough that I could pull this out without any problem. But sometimes, and if you look on YouTube once in a while, you can see video of people that weren't quite as careful as we are. So there's one I used to show that was, somebody brought their chair in. So they had a chair that the base of the chair was magnetic, and all of a sudden that chair got sucked right into the magnet. And they really, really, really had to work hard to get it out of there. And one of the other reasons that it's kind of a challenge is that we never turn this magnet off. So even though it's an electromagnet, it's got electricity running through it, the way that we make this such a powerful magnet is it's what's called a superconducting magnet. So I don't know if you ever heard about superconducting, but that basically means that we turn it on, we energize it, and then we keep it really, really, really cold. So liquid nitrogen is something you may have seen stuff about or had in science class. Liquid nitrogen is the stuff where it's liquid, and then you can take like a banana and dip it in liquid nitrogen and then use it like a hammer because it freezes it so solid. Liquid nitrogen is about 70 degrees above absolute zero. This magnet, the stuff in there, it cools it down to about 4 degrees above absolute zero. So this is about as cold. I think liquid helium is about the coldest thing that you can make. But that also means that once you turn it on and keep it cold, it stays a magnet forever. It doesn't actually need any electricity after that. The electricity will just keep flowing through it as long as it's cold. So when we go home at night, we turn out the lights, but the magnet is still on. Thunderstorm comes in the summertime, knocks the power out, this thing is still on. It's still a magnet. So every time we walk around here, we kind of have to make sure to check our pockets and that we're not accidentally bringing in stuff. When I was earlier in my career, I probably wiped out my credit cards about once a year from bringing them in and demagnetizing them. They would just not work at all after I was brought them in there. So you have to be careful that, things like your phone and that, it might not, suck it in there, but it'll do funny things to it and make it not work very well. So that's kind of the main safety thing with the magnet. Otherwise, just like any other magnet, your refrigerator magnets don't have any problem for your body. You could stick a refrigerator magnet on your head. You probably shouldn't swallow one, but putting it on your head is not going to make any problems for you. And so unlike, say, an X-ray or a CT, X-rays and CTs use a little bit of radiation for the scan, but you can have those every now and then it still is a little bit potentially harmful if you get lots and lots of them. But MRI, magnets, and radio waves, if you have a phone, this has basically got a radio transmitter in it, so that there is something you're carrying around probably most of the time. And it's exactly the same in there. I see a question in the chat. What's absolute zero, by the way? Absolute zero is basically the temperature at which stuff cannot get any colder. Temperature is kind of a measure of how much molecules are moving around and vibrating. Absolute zero means nothing is moving, nothing is vibrating at all. Absolute zero corresponds to about minus 273 degrees Celsius. So even though it can feel really cold in the wintertime here, minus 30 degrees Celsius, you still got a long ways to go to get to absolute zero. Question, good one in there about what are people with metal in their body like? In those cases, what we have is most of the time the kinds of metal that people have in their body is safe. So I'm going to show that. Actually, I have a couple other things here that are made of metal. So these are just big aluminum blocks. And aluminum isn't something that's commonly put in people's bodies. Typically, say if you broke your ankle or you broke your wrist and you had a pin or something put in there, it would be made out of something like titanium. Other things, if you have, say, something that's older people holding their arteries open, they would be a kind of a little wire mesh. But again, they would be made of something like titanium. There's certain types of stainless steel and that are able to put in the magnet as well. So what we end up with is stuff that will behave a little funny when we get here, but we end up being able to still scan people that have metal in them. The one exception is if you have a pacemaker. If you have a pacemaker, it's not because the pacemaker is going to get sucked out of your chest like alien style going out there. A pacemaker actually is programmed sometimes by magnets. And so the main problem there is we go put you in the magnet and it makes just like it would do to your cell phone, it makes the device behave badly and malfunction. And so maybe normally it should make you making your heart beat, 60 beats a minute. It might not make it beat at all, or might turn it off in there if you have a problem there. Is there a question out there?
What's a pacemaker again? I forgot.
A pacemaker is something that if your heart doesn't beat with the right rhythm, they implant an electronic device in there that sends the little electrical signals that make your heart beat. And so it's programmed to make it beat at the right rate. And so And then they can use magnets to be able to get information back. So if they need to speed it up or slow it down, they would do that. So we don't want the scanner speeding up or slowing down your pacemaker when you get in there.
One more question. What's
Sure.
that one where you like rub the things together and then you press it on their chest? Is that,
That's
like,
a
is that
defibrillator. That's a defibrillator.
Okay.
And that actually could be a problem here too, that if we do have an emergency in the scanner, so say, because obviously in the hospital, somebody is being scanned because they're sick. And if something bad happens while they're in there, it's a little tricky. Somebody has to, get them out of the magnet far enough that, yeah, like you say, that a defibrillator or something like that could be used. Although I will say, there's actually some research going on to be able to make them work in an MRI scanner. So we actually did a little research here a couple of years ago on exactly that, to be able to work with that. But almost any other type of material that is implanted in the body, at least is safe. The pictures might look bad, but at least it wouldn't harm your body to go in there. So for instance, these big aluminum blocks, nothing unusual about them right here. But again, hopefully I'm close enough, you'll be able to see. I'm basically going to stack them up when I get up there, and they should just fall over, because I'm not good enough balance. It's just a cushion on there, but let's see what's going to happen. So it turns out when you have something that is kind of an electrical conductor, this isn't quite levitating exactly there, but because of the way that these metal blocks, and particularly the fact that they conduct electricity, when they get really close to a magnetic field, they sort of do everything in super slow motion. And so you can see here, it's kind of just starting to tilt and fall over, but it's moving extra, extra, extra slow because of the way that the magnet forces are twirling around inside the metal blocks as well there. So you can just see that it's just starting to flow down there. Now it's finally going to fall down. There it goes. That was actually my best example yet. I did my best balance job for this one. So you can see that even though there's not anything attractive about it, it doesn't get sucked into the magnet, it still ends up doing some really strange things in there. Now, I will say we have actually one scanner that's an even more powerful magnet than this. And so when I get put into that one, it has also a much longer tube. I can't remember now if I showed you the length of this tube. The tube on this one is about 3 feet long or so. And so if you're in there, you feel like you're in a big pipe, but you can also then see out the front or the back. There's actually a little mirror on that. I'm going to jump up there in a second to be able to look at exactly what it feels like, or not what it feels like, but what it looks like when you're getting scanned in there. So whatever we're scanning, we have to basically slide you all the way down to the middle of that tube on the inside. And we also typically put you in something that kind of is close to the part of your body that we're scanning. So what's on there right now is what we call a head coil. And that's where we would slide your head in to get scanned. So I'm just going to jump up on the table to show if you were going to get scanned, this is what it would be looking like. So that's about where I'd be laying down. And then the motorized table would scoot you into the scanner there and the process would begin. Scans are noisy. By the way, I would probably take off my glasses in that case. The scans are noisy. I can't demonstrate it here very easily, but it's kind of loud in there. So we give you earplugs or maybe headphones. You can listen to music. If you look on there, there's actually a mirror on the top of that head coil. And that means when you're looking up, the mirror looks to the back and you could actually then watch a movie. We have a projector and a screen behind the magnet that you could actually watch a movie while you're in there, listen to it on the headphones, watch it on the screen. So that's another way, in addition to the fancy space theme that we have here, that we try and make it just be a little bit more comfortable for people, that they're not freaked out by the noises and all that are going on in there. I've had probably 200 or so MRI scans over the years. As I say, my hairline here is unrelated to the magnet. I have some heredity in that part of it there. So you don't need to worry that, the magnet is ripping out hair by the roots or anything like that. But I've had pretty much every part of my body scanned at some point over the years. I've learned a lot about myself, as it turns out. The question came up, it takes a long time to do a scan. It's anywhere from, probably the shortest ones we do are about 20 minutes. And that means we got to get things set up. That includes getting you on the table, slide you in, do a couple of scans, and then out. We do have ones that are longer than that so that we get more detail, or I'll show a couple examples, more types of scans. Some people are in there more like an hour. I think my personal record, I did do a scan for about 2 hours once. And that's, frankly, it's pretty hard to lay still there. I've had so many of them over the years that I just get drowsy and I start to fall asleep. So most of the time I just fall asleep in there. The downside of that is that a lot of times I fall asleep, I wake up, and then I don't have any idea how much time is left. So I don't know if I slept for 3 minutes or 30 minutes, but you can still talk to whoever is running the scanner over in the control room. They can hear you, so you can talk to them if you have any questions to ask about there. So that's just sort of the basic mechanics of how we get the scan and how things go in and out of there. I'm going to show you some things that we have scanned. As I mentioned, most of the time, of course, we're scanning people. But sometimes when we're just testing things out, we scan other stuff. So I'm going to share my screen and show you a few of the other stuff that we've scanned over time in here. So you can consider this maybe just a little bit of a quick quiz in here.
Is that an egg?
It is. I'm going to see,
No.
I got some harder ones though. And I got a follow-up question for this one. First of all, I'll give you a hint for the rest of them that things on this particular type of picture are brighter if they're a little bit more liquidy. So things that are kind of more like watery will show up brighter than things that are more solid and dense. So yes, this one is actually 4 eggs, of course. Here's my follow-up though. Is it a hard-boiled egg or is it a raw egg?
Raw.
It is a raw egg. So you're right, because as I mentioned, raw eggs are more liquid-like than a hard-boiled egg. Hard-boiled eggs don't show up very well on eggs. Okay, how about this one? This one's not too bad.
Onion.
This one is an onion. Yeah, sliced here like you probably have it on a sandwich or something, sliced the long way. We did this kind of funky 3D reconstruction on this one. How about this one?
Orange. No, grapefruit.
I would accept either answer. This happened to be an orange, but a grapefruit looks exactly the same way. So you can see the detail. Once again, this one was kind of sliced across. This one the long way down the segments. You can even see the little, here's your new vocabulary word for the day, juice vesicles. That's what those little tiny juice pouches in an orange are called. This would be a case too, if you went to Fairway or Hy-Vee and you thought, well, are they really giving me seedless oranges? You can bring them into our place and we can scan them for you and find out if they really are seedless. It costs you about $650 an hour, but if it's important to you, we could do that for you. How about this one? This is a little more exotic.
Kiwi.
That's a kiwi, yep. Same thing here. The seeds are really dense and dark on this one. The fleshier, juicier parts are a little bit brighter in these cases here. A little more exotic yet. Tend to see these around holiday times. Sorry, what was
corn.
that? No.
Corn?
Corn doesn't show up very good. It's not very liquidy. This is much juicier. This is a pomegranate.
Oh.
I don't know if you've had one of those and sliced it open. It was a long time before I ever had one, but same thing here. It's real seedy but juicy, and so you're seeing the juicy parts and the dark areas are just the seedy parts. How about this one?
Cantaloupe.
Yeah, so there you go. Cantaloupe, you can see kind of it's got all these little fibers and things in there, but also you can see kind of the seeds and things in the center of that. How about this one?
Pineapple.
Good, that is a pineapple. slice the short way, slice the long way. If you have only ever had pineapple in a can, you might not know about the big giant core down there that you can't really eat. This one's a little trickier. There's kind of two common guesses on this one. I want to get a little survey of different, let's see if you want to type it in the chat, or just I want to get at least 2 or 3 opinions about what this is. I heard celery as one guess. Anybody got a different guess? Wheat.
Asparagus? I don't know.
Asparagus, that's not a bad guess. I actually haven't seen the right one just yet though. And maybe you just don't like this stuff. I can believe that. I never liked it at your age either.
Lettuce.
No, this is broccoli. This is like the full head of broccoli. So again, if you saw it, if you only ever saw it chopped up in your salad or your Chinese food, you'd probably not see the whole big stalk of this here. And it's a little tricky also because the little floury bits at the end of this don't really show up very well. There's also these little white specks here. That's actually not part of the broccoli. We had this wrapped in plastic wrap, and it was in the refrigerator. When we brought it out of the refrigerator, it forms little water droplets, condensation on the plastic wrap. We can see the water droplets, but we can't see the plastic wrap. So all of that is.
We're learning about the water cycle and science in our class at school.
And so yeah, this would be another example of that. Okay, here's one more that probably most people have seen this, I think. Again, this is like we sliced it across. What was that?
Dragon fruit.
No, this one's technically a fruit or a berry, but most people think of it as a vegetable.
Potato.
It is a tomato.
Ooh,
So here again, if you sliced it open there, this would be the juicier parts, the more pulpy part around the edge. Now here's my challenge problem. This is probably not something anybody here has eaten before, but I guess if you were desperate, maybe you could slice it up.
Is it a flower?
It is a plant. I'll give you that much. It's not really a flower. I don't think this particular one has flowers. At least it didn't when we had it. We had this just in a little pot in our office here. Is
it a thistle?
You're getting in the ballpark. It does have lots of little spikes here, but it's something that probably more likely appear. Yes, it's a cactus, so a desert thing. And when they suggested we scan this at one time, I was a little bit skeptical because I thought, well, a cactus is a desert thing. As I mentioned, these pictures are mostly emphasizing liquidy parts in there. Well, a cactus is just going to be dry, but if you really think about how a cactus has to survive, it has to collect moisture through the water cycle as much as it can. And so it sort of holds on to that in the interior parts of it. So what you're looking at is kind of a map of exactly where those things are being stored within there. So yeah, just exactly as a couple people said in the chat, it's storing water in there, and that's how it's able to still go through all of its life processes. So that's the kind of stuff we scan when we're just testing out new ideas. We don't necessarily have to scan a person. We just need to check, does this work at all, or does it not work? But the real research stuff that we do when we're trying to answer, real scientific questions about the brain and that, we'll scan some brains. So, as I've been mentioning to other groups in here, in order to make sure I'm not invading anybody else's privacy, a lot of the scans you're going to see here, pictures are going to be of my brain. So you can look at me from the outside here and decide, whether this is an accurate picture of the inside of my head. So this first one, this is basically going to be kind of a left-right. It's as if you sliced me open left to right. And so looking at kind of a profile view. And so this is just coming in here. You can see now, this is still not quite in my brain yet. This is looking at just the edge of my head, so just a little bit at my skull at this point. You can't quite see everything yet. Now that I've broken into my skull, opening up in here, and now here's a good look at my brain. This one actually, the style of picture in this one, the liquidy parts, the fluid in my brain actually shows up dark. So normally there'd be some fluid in between all those little folds of the brain, but that's being kind of suppressed in this kind of picture. So the other parts that are kind of bright in here are blood vessels. So there you can see this is probably my carotid artery coming up and down through there. So we can kind of see those little details. And the spotlight. So down here, my carotid artery, other little twisty arteries within there. There we're right at the center. So this is the full-on profile view. So my cerebellum over here, my spinal cord and spinal column of vertebrae, nose sticking out there, of course, my mouth here on the left-hand side. As I say, things that are air spaces show up dark. On this particular one, there's fluid in here, cerebrospinal fluid. That shows up dark on this particular one. But this is a real nice detailed picture of my brain. And I actually have these for many, many years, so I can kind of see how my brain is changing over the years, hopefully not by very much. We're pretty much symmetrical, so the other side looks largely the same. Here's another one. Again, here's one that's that same kind of side view, so another profile view, not much different here. But I'll do one here. Here's one. This is my what's called an axial view. And this is, instead of slicing me left and right, it's slicing me top and bottom. So right now, this is down about at the bottom of my nose. So it's as if you cut me open right through my jaw and my nose and that. So you can see my nose kind of up here. If I move up a little higher, again, I might have had a cold that day. It looks like my membranes in there are a little flamed up there. There's my eyeballs. So in this one, the scan is a little different because we make the bright fluid things look bright on this particular picture. So there's, as I say, right at the level of my eyeballs through there. And then we go up higher and again, see throughout my brain. These sort of Swiss cheese holes here are also blood vessels. So on this particular type of scan, the blood vessels show up dark. It just shows the opening where the blood is flowing through them. So this is not areas of my brain being eaten away by worms or anything like that. And what you then have, there's the fluid again, the cerebrospinal fluid within the brain. And then we just keep moving up, top, 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 all the way to the top. It's interesting, actually, that a lot of times, say, people that are reading these for healthcare, they like to see multiple types of pictures because different types of tissues show up differently on them. And so if they see something that's bright on this picture on the right and dark on the one in the middle, that probably means it's fluid. If it's bright on both of them, maybe that means it's something fatty. If it's dark on both of them, maybe that means it's something more fibrous. So they can tell not only about what's the shape of something, what size is it, but they can tell a little bit about what it's made of. And that also is something that's kind of unique to MRI, just by programming it differently. So we have people that do mostly computer science kind of programming stuff working on the magnets. We also, of course, have people in neuroscience that are looking at the brains themselves. As I mentioned, my background is in biomedical engineering. And so I work both with the programming parts of it and some of the physics aspects of it too. We have people in physics that work on this stuff. Now, brains, as I mentioned, is probably the most common thing that we look at, but we also do some other parts of the body. This one, again, might not be able to tell. This is down in the chest area. And this maybe doesn't look too impressive yet until we do something like a movie version of this. So you can probably guess now what this is, what's moving in there. That's the heart. So this is a beating heart, yep. So this area here is the left ventricle. So that's the pumping part of the heart. And then the right ventricle over here. So the bright stuff, go ahead.
Go ahead.
I'm just saying the bright stuff in the middle there is the blood within the heart.
If you go to your right, is that like the kidney part or is that your liver?
So down here, right underneath is the liver. I think this is probably also liver wrapping in there. This might be your spleen, kind of this other thing here. The dark area above here is the lungs. And you can also see just kind of barely in view there, there's another big abdominal blood vessel within there. This is kind of hard because it's sliced at a weird angle. So even I don't know the anatomy real well within this, but we're trying to get a good cross-section view of the heart in this case. So as I mentioned, we do hearts, we do livers specifically sometimes. We actually have one that we look at the kidneys. And sometimes we look at some real unusual subjects. So I'll finish off. I think I just have a couple of minutes left here. Let's take a look at this subject. This is, in fact, I'll give away, this is a brain, but this is a relatively unusual subject that there's something a little more interesting maybe than average about this subject. So you can see there's the eyeballs again. They're kind of a mix of dark and bright in this one. And again, this is their brain in there. So anybody want to take a guess at what might be unusual about this subject?
Those parts that are near the back.
Down here, this kind of stuff back here.
Keep going to your left, more farther back.
Oh, way back here.
Yeah, that part. Isn't it?
So that is
That
different than most people. But the main reason is because this is a mouse. So we actually have another scanner in our area here that is small. It has a real small opening, and we can do mice. We put them, well, they're breathing some anesthesia, so they're asleep. So we can put them down to sleep, put them in the scanner, scan them for 20 minutes, 30 minutes, maybe even up to an hour. And then we let them wake up and they go on their scurrying way. We get these really good pictures of their brain. And the reason is that a mouse will be fully developed within a few weeks. And so because we have all of these genetic types of mice that mimic human conditions, we can learn a lot about those much more quickly. And MRI is a way that we can look at them without having to do anything but just give them some anesthesia. So it looks like our thing.
It says it's almost time to go.
Yep, I say we're just about ready to end here. So that's what I'll leave you with, little scurrying mice. And thanks for coming in and enjoy the rest of your time.